In this tutorial, we are going to follow the instruction to perform the harmonization step using the pipeline LHS. You can find these guidelines on our GitHub at Mail Project and LHS. Before to use the pipeline, you will need to ensure that you have installed either the Docker container or the Singularity container. And in this tutorial, we are going to look at how we can prepare the data to run the harmonization and also how we can compute the harmonization parameters. So we can follow these guidelines. The harmonization step is an optional step that we recommend to do to remove the site or scanner specific bias that can be in your data. To compute the harmonization parameter, you will need to gather at least 20 subjects, which can be controls, patients, or a combination of both, that have been acquired on the same, under the same protocol, so the same scanner, but also the same sequence. To run the harmonization, you will need to decide on a harmonization code, which need to start by H and can be followed by a number such as H1 or H2. And we are now going to follow the guidelines to organize the data. To prepare the data, you should have already downloaded the LHS data folder, which is composed of 4 folders and some files. And you will need to organize your MRI data. Of note, the LHS has been developed on scans acquired at 3 Tesla, and therefore we cannot guarantee the accuracy of the results on other scans that have been acquired either 2D or at 1.5 Tesla or 7 Tesla. So to prepare the MRI data, they need to be formatted in the bits format, which is a standardized format, and I'm going to show you an example here. So for example, in your input data, I have 20 subjects, so 20 controls, and for each of these controls, I have a folder that needs to start by sub and then the ID. And on this folder, I have an ANAT folder, and on the folder, you have the T1 data. And this file needs to also start by exactly the same IDs in the folder and have the T1 weighted flag here. You can follow the instruction here to know much more about how to organize your data in bits datasets. And you can also look at the bits instruction if you want to adapt it. So once the MRI data are organized in the bits format, you can go back in the LHS folder, and we need to now prepare the demographic information. So to run the harmonization, you will need to have the age at scan and the sex of all the participants. So you will need to use the demographic file. You have an example here, and I've created an example for my harmonization. In this file, you have multiple columns, and for each subject that you want to use for the harmonization, you will need to provide the ID, the harmonization code, so H2 for me, what their status, so if this is a patient or control. So this is important for the harmonization to precise if some of the subjects are controls or are patients, the age at preoperative scan, the sex, and the scanner, which should be all the same here. Once you have prepared this, you can save. So the last step now is to prepare your list of subjects that you are going to use for the harmonization. So you just need to put all the subjects in a text file on each separated by a line. And once we have this, we're ready to start running the harmonization. Once you have prepared the data, you can go back to the second step of the harmonization, which is to run the pipeline to get the harmonization parameters. So for that, you can open a terminal and go to where you have extracted the LHS codes. So for me, it's my code is here. So I'm going to click right and open a terminal there. You can see that this is the codes that I've downloaded from the GitHub. And I'm going to check that on my compose files, I have the volume that is pointing to where to my LHS data folder. But this should have already been done during this installation process. So if you are running with Docker, you just need to copy this line and paste it into your terminal. And then you need to just change the harmonization code, which here is H2, the subject list, which is and your demographic file. So you can now run this command and you can see that it's starting. For users that are using a singularity container, you can find the command line here. It's a bit different. You will need to first export the path to where the LHS data folder is found. And then you will need to run this command provided here. So it's slightly different, but the output is exactly the same. So you can tune this command by removing or adding some flags. So for example, this specific command has the armo only flag, which means that it will only compute the harmonization parameters and will not perform the prediction on those subjects. However, if you have, for example, some patients and you would like to also predict on those patients, as well as computing the harmonization parameters, you can remove this flag. You can also add another flag, which is as a parallelize flag, which enables to run in parallel multiple subjects. But this is only working if you have multiple CPU on your machine. Once the command has finished to run after several hours, the harmonization parameter will be saved and you will be able to use them to predict on a new patient. And for that, you can follow the guidelines here.